Okay, so where I left off, I was talking about creating a registered user button. Okay, from here I'm going to talk about basically, I'm just going to leave this for a second, and I'm going to go and just talk about some principles that we're going to use in order to register. We're going to create a user manager who is a solid sort of guy, my Uncle Bob tells me. I said that in the header because basically we're going to be using solid concepts of object-oriented design in order to design this. So we're going to have SOLID is an acronym for Single Responsibility Principle, Open-Close Principle, Liskov Substitution Principle, Interface Segregation Principle, and finally Dependency Inversion Principle. These are things that some programmers have never heard of, but I'm just going to touch on them today. I'm not going to give you a huge in-depth study of them because I think really each one of them deserves their own videos. But I thought I'd just bring it up because it's what I've sort of planned this around, and I'd just like you to appreciate it, I guess. Okay, so let's get started. The single responsibility principle is basically a class should only have one single responsibility. There should be one set principle behind a class, and it should only be set up to do that. So what that means is a user manager should not be set up to I don't know, worry about orders. It should just be set up to worry about the users. This doesn't mean that they can't have multiple attributes and methods. It just means that it's for managing one set thing. So you wouldn't have a user manager dealing with transactions or anything like that. It'd just be for dealing with the user's information in the database, I guess. This will all become more clear in the thing, in the further tutorials. Open-close principle. This is basically classes are open for extension but closed for modification. For example, you can't change anything in the string class. You can't. You perhaps can overwrite some things, but you can't change the attributes and so forth of the string class at all, really. But you can extend it. And how you do that is you write a private or a public method you can do, void, and then the method name, and then this, that's a keyword, and then the class you want to change, then the parameter. So this would mean that you might have a string declared name and set it to James, and then you could write name, rewrite, and run it. And that would be, instead of having the James in it, or another class, it would just be part of the string class, so you can, the code just looks cleaner. I've not changed anything in the string class when doing this, but it's instead added an additional method for when I need it, basically, in the project or wherever. Let's go substitution principle. This is one that I quite like. It means that basically objects in a program should be replaceable with instances of the subtypes without altering the correctness of the program. So what does that mean? Basically, for example, our gold class shopping cart, or a standard or silver, should be able to do everything the abstract shopping class should do. In fact, anything that inherits from something should be able to do everything the base class does, and generally more, because that's the whole point of it. Yeah, basically it's sort of something to think about in order to stop people being too enthusiastic about code reuse, because they really need to think, well, does this extended class do everything that the base class that I suspect that I am saying it inherits from does? Okay, this one, interface segregation principle. This is one that I sort of yes, it's easy enough, the principle, but it just needs a bit more explaining. So that's what I've done here. Let's just say, well, I'll just explain. Many client-specific interfaces are better than one general purpose interface. This means basically you don't overfill with a class method, with methods that aren't directly related to the class. There's a term, fat interface. This means that you've got too many methods and so forth in it. This is done so the user can have more reusable code, and the user doesn't have to write methods for classes which they will never use. Let's just say a real-world example is we have roast disposal units, and we need a program when they get sent to the shop, and they're like this. These are three ones here that I've highlighted are the rubbish disposal units that we get, and you're the programmer that needs to program them. Okay, so you set up a class for recycle, and you set up a class for dump. So they might be abstract classes, and then there's three other options. There's 4 types of rubbish. So there's basically biomedical, so doctors and stuff, or syringes, toxic, so acids and so forth, nuclear, doesn't need explaining, and clean, so I don't know, lolly wrappers or something. But basically then you might have interfaces, because C# only can inherit from one class, and then the rest must be interfaces. So you'd set up these interfaces, biomedical, toxic, nuclear, and clean, which have all sort of the code for dealing with the rubbish, or code sort of contracts of what they need to program. So from there, when you're setting up machine 1, let's just have a look at that. Machine 1, this one, it can recycle, but it can only recycle biomedical, toxic, and clean. And it can dump though, however it can only do biomedical, nuclear, and clean dumps. The second machine, this one, that can only do recycle of biomedical, toxic, and clean, and it can dump biomedical, toxic, nuclear, and clean, but the only thing it seems it can't do is recycle the toxic one. So we just basically, you'd have the class. I'll do a quick one. Let's see. So you might have this. So shop and go. Let's just say this is a recycle. Then you might have biology. Sorry, I'll just copy and paste this. Biomedical, toxic, non-clean. So let's just say we're doing that one. Okay, we're going to do machine 2. Okay. I won't. Okay. You don't really need to do this. I'm just showing you. So public class machine 1, right? Or is it 2? It's 2, but yeah, anyway. Okay, so recycling, machine 2 does just nuclear. Doesn't do clean. So there we go. And then so it might be that we have dump class, and this is, this one does everything. So we go Control V. So okay. obviously you can't really have two classes that are sort of the same, but this sort of is just to explain it. So you see that machine 2, this would be the recycle class, so just should be the dump class. So anyway, you'd see from this that there's two things, both classes are from the machine. So this would be programming both the interfaces. And then you'd have each of these, and it would, you could say, if this is a real class, you could have implement the class within it, and it would bring in all the methods from that. But yeah, basically, that's sort of just how you set up the code contracts, and you'd have a recycle with all the methods, and it'd come in with all the methods, and you might have to override one or two, as we did with this, just overriding that. And you might need to declare an attribute or something, and do the interface for the nuclear. I hope I've explained that sort of a bit better, but as I keep saying, it really is the case that it's just something that requires a video by itself. And then finally, dependency inversion video. So dependent upon abstractions need not depend on concretions. This means, for example, that classes are to be able to plug into any other class, and the class can be easily changed for another. A good example of this might be that you have a car class, and if you want to change the engine, it should be just easy enough as changing the class. So you might have an interface for a class of 500 power CC engine and change it to a 700 power CC engine, and it should just be easy enough to change it and not have the whole class blow up in your face. But yeah, basically these are principles that we're going to apply to our UserManager class, and that's just something I thought you should be aware of, and it'll become more clear when I show UserManager and you have a look at it and take it all in. But yeah, otherwise just look into it a bit yourself, but it really requires me to make one video for each of these principles. Okay, so next up we're going to actually make the UserManager, so yeah, stay tuned.